So in this video we are going to make a Milwaukee palm router guide rail adapter. So let's just have a walk through what you get with the standard Milwaukee palm router kit. You get this regular base here with an edge guide, which personally I've rarely used. Every time I've tried it's wandered all over the place. Definitely user error, so don't think I'm trying to blame the tool. Second, you get this chunkier guide that comes with the plunge base. So I made the decision to create something that sits within this existing profile that the rail has, and I could use then the rail connector as a model for taking measurements. And in this video we're going to take two different approaches to the same problem. One, we're going to engineer in aluminium, and the second we're going to do completely out of hardwood, and I'll explain the pros and cons of both. And stick around to the end of this video because I'm going to go through step by step how you calibrate the guide in relation to the rail to ensure that you have accurate and repeatable routering. I'm not a big fan of cutting aluminium with a table saw. I had to fight practically every cut. Admittedly, I was using an older blade because I didn't want to ruin one of the newer blades, but it really did struggle. It was always trying to resist as it went through. So confession number one, the section of aluminium that I have does not fit the full width of the slot in the rail. I'm using scrap, so if I was going to buy new, and if you were going to do this exact same section yourself, I would say just buy more width than you need and cut it down to suit based on the step process that I'm following here. What I managed to convince myself was a good idea was that once I've separated those sort of two halves of the guide, that if I put threaded bolts between those two sections, one side being threaded, the other being loose, it would give me the ability to provide some adjustment to either make it tighter or looser in the rail. In hindsight, this was desperately over-engineered and also took far more time than I really should have spent on it. So confession number two, I'm not really set up to do metalwork. I just don't have the equipment. So this was a bit of a sort of budget. Here I'm making my own grub screws, for example, to fit this adapter. The other choice I made was to use some hardwood in between the two sections of aluminium to help for two purposes, but mainly to try and help with the smooth flow of the guide within the rail. It tended to stick. Aluminium to aluminium didn't seem to flow particularly smoothly, probably because of the level of my kind of workmanship and engineering, but hey, there you go. I can only work with what I've got. In the end, the rail worked okay. With the larger plunge base, it is a heavy piece of kit though, so that's why I decided to go back to the drawing board to try a much more simplistic approach. In this version I used mahogany, which I cut to the exact width of the profile of the rail. I could tell instantly that this was going to be a better option for two reasons. One, because it can drop straight into the rail without having to slide it on or off one end. But also the wood was a much smoother run than aluminium to aluminium. All that was left then was to fit the handle again. I probably could have gotten away without having the handle. However, I just think from a safety and control perspective, it makes perfect sense to have one. So as for which option is best, I will do a follow-up video because obviously I've only just put these together, so I think it would be unfair to call out a winner straight away. However, my gut tells me that I will use the wooden version more. A, because it's quicker and more convenient. You don't have to slide it off the end of the rail like you do the other one. But also it's quite smooth and easier to control than the weightier option with the plunge base. So I just want to run through how you can make this very accurate for repeatable cuts. It's kind of a calibration, if you like, so how we can position the rail in relation to the center of the router itself. So first off, I took and forgive the ignorance, a V-blade, a pointy blade, just made a score mark on some material. You can see here where it aligns already to the center marks for the router. I then picked an arbitrary figure. I said 50 millimeters from the edge of the rail, or the tear guard, if you like, at the edge of the rail, and then I can just simply screw down the fixing, and then I know that any marks that I do in the future are exactly 50 millimeters. If you've taken a different approach to this problem, I'd love to hear from you, or if you have any thoughts and suggestions to improve what you've seen in this video, also dying to hear from you. I really do wish Milwaukee had come up with a solution to solve this problem themselves, but hey ho, if they don't, it's left to us to engineer something. Anyway, thanks for watching. See you next time.